and midpoint's another one. And midpoint is going to be a big word that we'll talk about for different times of the year, and means a couple of different things, or we do it a couple of different ways depending on what it is the midpoint of. But it's just like it sounds, right? It's, if I have a segment, the midpoint of that segment would be the point that is right in the middle of that segment. It splits it in half. And yesterday we kind of saw that, where if I had a segment and I tell you that these two pieces were congruent, then we eventually came to the conclusion that that point had to be in the middle, right? And which in that case we'll call it the midpoint. We didn't really call it the midpoint yesterday, but based off what we know now, we can do that. And so here's what the picture yesterday looked like. I would have a segment. And then I have a point in the middle. And as of right now, do I know that that point's in the middle? It's between A and B, but do I know that it's right smack dab in the middle? Same distance? Okay? And that's one of the hard things I think about geometry, is sometimes looks can be deceiving. And maybe not right now, but eventually you're going to see a picture like this, and this segment and this segment may not be equal, even though they look like they're equal. Okay? But, I'm just telling you that so you keep that in mind as we move forward. But if I put these two markings on it, now we know, without a doubt, that M is the point right in the middle. So what we would say here is that M is the midpoint. And then we would say that AM is equal to BM. And what does it mean again when I don't put a symbol above AM and BM? Distance, okay? Distance or length, okay? Distance between B and M is the same as the distance between A and M, okay? Segment bisector. A segment bisector can be a point, it can be a line, it can be a segment, it can be a ray, it can be any of those geometric figures that we've talked about up to this point in this chapter. And what they're going to do is they're going to take a segment and split it in half. So once again, if I put AB up here and say AB is my segment, then I could draw a line right here. And I'm just going to call it line L. And as long as I put these two markings on it, then that tells me that line L is the segment bisector of segment AB. Hey, it doesn't have to be a line like I drew there. It could be, let's say I have a segment here. It could just be a point, which would be the midpoint, right? It could be a ray. It could be a line like we have there, or it could be another segment that's splitting it in half. So it could be a point, a line segment, a ray, or even a plane. Okay, a plane would be a flat surface that cuts it in half. There's a lot of things that could cut this segment in half. Doesn't have to just be one particular figure. Okay, we got the skateboard here, and we know that XT is 39.9. I know it's kind of hard to see on here, but there's a little tick mark here and here. It kind of blends in with the picture. What does that tell me about xt and yt? They're equal, okay? Because it has that little marking on it, we know that xt is equal to yt. They are the same length. Okay, I know that xt is 39.9. So what would yt be equal to? 39.9, right? Because they're the same length. But then here's where we got to be careful. You've got to be really careful about what it's asking for. In this case, we're looking for xy. We're looking for the entire length of that segment. So xy is what we are looking for. What would I need to do to find xy? Yeah, you bet. Just add these two together, right? This one's 39.9. This one's 39.9. So I could just do 39.9 plus 39.9, or even easier, I could just do 39.9 times 2. So here I would say that xy equals 79.8. And that would be our length. All right, the next one. Identify the segment bisector of VW. What type of figure do we have right here? Is it a line? Is this a line right here? It's a ray, right? Because it has an arrow on this end, but it's not continuing on. Okay? It doesn't continue on forever. It has a distinct stopping point right here. So this is my end point, and it continues on in this direction. So this would be your ray. Okay? So this is a ray, and when we label a ray or name a ray, we always start with the end point and go through, MN, not MW, my fault. MN. And it is a ray. So when it says identify the segment bisector of VW, they're asking what kind of figure and then name the figure that is a segment bisector. We know that this is a segment bisector because, why? Got the markings, right? The markings tell me everything. If these markings are not here, then we don't know a whole lot of information. But because this marking and this marking are labeled on that picture, we know those two segments are congruent. So what that means is we can say that VM is equal to WM. The length of VM is equal to the length of WM because they're marked the same. We don't know the actual length, right? And that's what it's asking me here. Find the length of VM. How long is VM? And you can't say 4x minus 1 for your answer, okay? Your answer is going to be an actual length. It's going to be a number. How are we going to do that? Any ideas? So we haven't done this for a while, okay? But remember what I told you one of the first days? We get, not have to, we get to use a lot of algebra and geometry. And guess what? Here's one of those first opportunities, okay? What do I know about these two expressions? They're equal. So what can I do with them? If they're equal, we can set them equal, right? If they're equal to each other, we can set them equal to each other. We know that VM is 4x minus 1. We know that WM is 3x plus 3. Did we solve a lot of problems like this in Algebra 1? Yep. Okay, so we got some skills, right? We got some skills we can bring into geometry with us. What would be my first step in solving for x here? Okay, we could add 1. Yep, I'm all right with that. You have a couple of things you could start with, but adding 1 would be a good start. And if I add 1 to the right, where am I going to move the 3x to? We're going to move it to the opposite way, right? So we want the x on one side, we want the numbers on the other side. And what I'm showing you here is you can kind of do 2 steps in one here. You can combine it into 2 separate steps if you want to, but just to save yourself a little time, since I added 1 to the right, I could move 3x to the left. We're combining 2 steps into 1. 4x minus 3x would be x, and then 3 plus 1 would be 4. Now here's the part you got to be really careful of, and this is probably one of the things that gets missed more than anything else in geometry. There are a lot of different things that I could find in this picture. Sometimes the question may say, find x, and in this case we would be done, right? I found x, x is 4, that's my answer. But it's not asking me to find x here, it's asking me to find Vm. And what we know about Vm is that Vm is really 4x minus 1. And we can take the work we just put in, and we know that x is 4, so we can take 4, and where are we going to put 4? In for x, right? Because 4 and x are the same thing. So I'm going to take 4, and I'm going to move it in over here in place of x. We're going to substitute it in. So this would be 4 times 4 minus 1. And Vm is 15. Okay, it's a lot of work to get there. Okay, I will also say this. Sometimes it may ask me what's Wm. Sometimes it may even ask me what is Vw. And so in that case, I would have to say this is 15. This is 15, and then VW would be 30. Okay, you could just add those two together. So that's what I was saying. There's a lot of different things that you could find. I could ask you a lot of different questions there. You got to really be careful and read the directions carefully. Okay, next one. Identify the segment bisector of PQ. So here's PQ. PQ is a segment. Okay. What kind of geometric figure is bisecting PQ? It's a line, okay? Good. It's a line, and we would call that line L. We talked about a lot of different ways to name a line. And when it has an M right here, M is referring to where those two intersect one another. I know there's not a point there, but we know there to be a point there because it's where two things are intersecting. Are there any other points on this line? Do we have any other points here? No. So can I use 2 points to name that line? No, because we don't have them. I can't just make one up, right? It would already have to be given to me. So line L is the only way that I can name that bisector. Line L is my segment bisector. And I could even say line L is the segment bisector of PQ. Segment PQ. Okay, second step. Find PQ. Okay, PQ is the length of the entire segment, the big segment, right? Once again, here we have our 2 markings. Those markings are extremely important because it tells me that these 2 segments are congruent. So we know that PM is equal to QM. And then we can substitute our information in. 5x minus 3 equals 11 minus 2x. And now we solve for x. Okay, where are we going to start at? We got a couple of different things we could do first. Okay, +3 would be good. I'm good with that. It's one way we could do it. Okay, and because we're moving 3 to the right, that means I got to move 2x over here to the left. Notice what's in front of the 2x. What do we got? It's a minus sign, right? So we got to add it. We have to do the opposite operations to the other side. So we're going to add 2x, add 2x. So over here we have 7x. Over here we have 14. And now we can get x by itself. So we divide by 7. And we get x equals 2. Okay. What's it asking for? Well, it doesn't say what's x. It says what's PQ. So what are we going to do with 2 now? Plug it in. Yep. So 5 times 2 is 10. 10 minus 3 would be 7. That side would be 7. On the right-hand side, 2 times 2 is 4. 11 minus 4 is also 7. Okay, another good thing here is those two should be the same. If they're not the same, I've done something wrong. Okay, they both have to be the same value. They are the same value. They're both 7. And so then to find PQ, 7. 7 plus 7. PQ is 14. And that's our answer. Okay, questions on that? I will tell you this, guys, if you're struggling with the algebra part of this, or if you need help with it, please get with me, okay? Algebra is going to continually be a part of what we do in geometry, and if you're struggling with some portion of it or have questions about anything, so PQ, ask, okay? Always ask, and I'll be glad to help you out. Okay, the last part of what we're going to be doing today is what we call the midpoint formula. The midpoint formula allows us to find if I have, let's say, 2 points on a coordinate plane, and I want to find the midpoint of that segment, okay? We've already talked about it a lot today. The midpoint, we know, is the point that is halfway between the two endpoints of that segment. So it's going to be the point that lands somewhere right in the middle of this segment. And I'm just going to kind of eyeball it here, okay? And say that's my midpoint. I have to find out what is this ordered pair right here, okay? What would be that ordered pair? Where would that be? Okay, so in order to do that, I'm going to label this one as point A. I'm going to label this one as point B. My formula would be x1 plus x2 divided by 2 and then y1 plus y2 divided by 2. All that we are doing here is taking the average of something. If I scored an 80 on my first test and I got a 90 on my second test, how do I find my test average?
Add 80, 90, and then divide by 2.
That's right. You just add them up and divide by 2. Okay? And that's all we're doing here. We're finding the value that's right in the middle. When I find the average, we're finding the middle value, the mean, the average. A lot of different words for it, but this is the midpoint. Okay? But you're doing it for your x values, and then you're doing it for your y values. You're doing it twice. And then you write your answer as an ordered pair. Okay? You do not need to draw yourself a picture here. If you are a visual person, you could draw it, but I think that's, you know, and maybe Big Ideas asks you on some of these to draw, put it onto a coordinate plane. Because I know on yesterday's assignment they had us do that a couple of times. But you do not have to do that. Okay, so let's look at this first one here. This one is x1, y1, x2, y2. And all that means is first x, first y, second x, second y. We got 4 values. We label each one. These also could be flipped around. I don't care which one you label as x1, y1 and which one's x2, y2. They could be flip-flopped. Doesn't matter. And so what we're going to do then is add 1 plus 4 over 2. And then negative 3 plus 2 over 2. And then we just got to do a little simplifying. 1 plus 4 is 5, so that would be 5 over 2. And then negative 3 plus 2 is negative 1, so that would be negative 1 over 2. And that's my order pair. My answer is an XY ordered pair on these. Okay, same thing down here. This is X1, this is Y1. Oh, no, never mind. This one's a little bit different. Okay, I thought that was on the next one. Okay, I'm going to show you a little trick on these. Okay, they are giving me the midpoint. And they're giving me one of the endpoints. We have to find K. So what we're saying is that this point is halfway between this point and this point. Okay? Some people are able to kind of do this like in their heads. Okay? And I don't necessarily have an issue with that, but I'm going to show you kind of a trick the way I like to do this. And I'll show you another way to do it, and it's kind of up to you how you want to do it. But let's do X values first. If I was going to go from 1 to 2, how far am I moving? 2. You're moving 1, right? 1 to 2, we are adding 1. And that gets me halfway. So guess what we have to do to get to the other side? We got to add 1 again, okay? And if my X value is 2, and I add 1 to it, where do you think this X value is going to be? 3, okay? Be a 3, okay? Here's how you can check it. Is 2 halfway between 1 and 3?
Yes.
Here it is, okay? That's how you can kind of check. Okay, now let's do the Y values. So I do the X's on top and I do the Y's on bottom. Okay, now here's where you got to be a little bit careful. As I go, I start at 4, I start on the left, right? And I go back to 1. How far are we moving to get from 4 back to 1? 3. And we got to remember that it would be a minus 3. And then we're going to subtract 3 more, because that only got me halfway, right? So now, to go from 1, what would happen if I take 1 minus 3? So we end up at a negative 2. That's my order pair. Okay. Here's how you can check it once again. Is 1 halfway between 4 and negative 2? Just think about a number line, right? Think about where 1 would be. I got to go this direction to get to 4, and then I got to go the other direction to get to negative 1. 3 units either way. For me, I kind of like to do it that way. I think it's kind of a visual way of doing it. You kind of are using a number line to visualize that. I'll show you another way that you could kind of do it more algebraically, and then I'll kind of leave it up to you which way you want to approach it. Okay, for C, the easiest one of these problems is when they give me the 2 endpoints. Okay, and what might not be a bad idea is the endpoints are the end of the segments, right? And that's what we know here. This is negative 4, 3. This is negative 6, 5. You don't have to go through the work every single time to label it, but I'm just doing it for your benefit so you can kind of see that. x1 plus x2 would be negative 4 plus negative 6, and then divide by 2. Don't forget to divide by 2. It's pretty easy to forget that part. And then 3 plus 5 divided by 2. Negative 4 plus negative 6 would be negative 10. Negative 10 divided by 2 would be negative 5. 3 plus 5 is 8. 8 divided by 2 would be 4. Okay, the other way, and you could kind of do this visually, like if I had negative 4 and negative 6, does negative 5 fall right in the middle of those two? Yeah. And if I had 3 and 5, does 4 fall right in the middle? Yeah. So I almost could do this one visually too, right? Just think about what number falls in the middle. The part that sometimes gets a little bit tricky is when you start throwing negatives in the mix, and that is the part that kind of confuses this sometimes. All right, last one. Here's another one of those where we are trying to find an endpoint. Okay, so we have the midpoint. The midpoint is negative 1, negative 2. TU is my segment, and we know U is at 4, 4. We have to find the point that's on the other side of that segment. This is the halfway point. This is why it's helpful to draw the picture. M is the point that's in the middle. It's the midpoint, right? So if you don't draw this picture, I think you're probably it's really easy to get confused by this, okay? You also have to read the directions. I already know the midpoint, so I'm finding the other endpoint, so we don't just want to add them up and divide by 2, okay? So you got to be really, really careful about that. Okay, I told you I would show you another way, and there's a lot of different ways to kind of approach this. I just tried to do it because I think there's a lot of different ways that a lot of people see things differently. The midpoint formula says x plus 4 divided by 2 equals negative 1. So here's another way that we could do it. The reason I don't love this way as much is because you have to basically solve 2 equations out. I kind of like the visual part and the representation part because I think it's a little bit quicker and easier. Okay, for the y value, we're going to add up the 2 endpoints, y plus 4, divided by 2 equals negative 2. So there's my 2 equations. If I was going to solve this one first, what do I got to do to get x by itself? What do you think would be our first step? What do we got to get rid of first? Over here. Trying to get x by itself. Before we subtract 4, we got to get rid of the 2. And right now it's divided by 2, so we have to multiply by 2. Okay, so we're going to multiply by 2. And that gives me x plus 4 equals negative 2. And now, Xander, now you can subtract your 4. And we get negative 6. Okay, the good thing is that when I do the second equation, I'm doing essentially the same steps. Okay, first step is we're going to multiply by 2. and then subtract 4. Hi there. Thank you. Okay, so this would be our answer, okay? And if we wanted to verify if it works or not, okay, is -1 halfway between 4 and -6? You could check like the number line and make sure that it works, okay? Same thing here. Is -2 halfway between 4 and -8? And it should be, okay? If it's not, then you got to figure that out. Okay, so what do you guys think? What, if doing this problem down here, I could have either done it this way or done it this way, right? This took a lot of work and a lot of writing, right? That's why I like doing the other way of doing it, okay? But sometimes that doesn't, sometimes people's brains don't work that way, and I get that too. So that's why I show it both. What would you guys prefer? What do you think? The first one? Okay. Okay. Does anybody like this one down here better? You like the first one, Landon?
Well, the one on letter A or whatever, are we able to do that for every single one?
So we can't do that for every single one because on that one we were finding the midpoint. And so the difference on B and D is that they gave us the midpoint.
Okay.
Okay. So if you're trying to, if it says find the midpoint, then yeah, you can do that on any of them that say find the midpoint. Okay. And that's what happened on C also, is it says find the midpoint.
Okay.
Okay. But for B and D, that's where we had to use a little bit different direction. Okay. Any other questions on that? Okay. Try to practice, maybe practice both and see which one makes more sense to you. Those are a little bit tricky, okay, because it gives you the point that's in the middle, and it's not just a point, it's an ordered pair. Assignment should be up. 1-3 day 1, I think is what it's called. Tomorrow we'll have 1-3 day 2. We've got a little bit of time here to work, so take advantage of the time you've got. You've got about 12 minutes or so. That way if you have some questions, you can ask the questions.